Hello everyone. Welcome to the solution of LeetCode problem 1457 named Pseudo-Palindromic path in a binary tree. In this problem, we are given a binary tree where node value are digits from 1 to 9. Now here, a path in the binary tree is said pseudo-palindromic if at least one permutation of the node value in the path is a palindrome. Now we have to return the number of pseudo-palindromic paths going from the root node to leaf node. So here let's understand the first example. The root is 2, which has 2 children, 3 and 1. 3 has 2 children, 3 and 1. So here the path from 2 to 3 contains 2, 3, 3. And if we rearrange this 2, 3, 3 into 3, 2, 3, then it will become a palindrome. Similarly, for this path 2, 1, 1, if we rearrange it in like 1 to 1, it will become another palindrome. So here we can see that there are two root to leaf path which is palindrome. So we have to return 2. I hope you understood the problem statement. Now let's move on to the algorithm. So here, to understand the algorithm, we have taken the similar example. Now, we will solve this problem by using the DFS and by using the map. So how basically this map comes into play? Suppose let's understood this path. Here 2 appears one time, 3 appears 2 times. So here we will check the frequency, which frequency or the number of frequency which have the which have the odd parity. So here we have seen that this is 1 and 1 is odd number. So here in the frequency, the number of odd number is 1. So if the frequency of odd number is less than or equal to 1, we can say that the sequence will become a palindrome. So here, suppose we can put 1 into the middle and put both of the two into the first and into the last position. So it will become the palindrome 2, 1, 2. So here, let's dry run the example by using this tree. Initially in the DFS call, we are at the position 2. So we have to increase the frequency of 2 by 1. Now from 2, we are at this node 3. So we have to increase the frequency of 3 by 1. Now from 3, we are at this node 3. So we have to increase the frequency of 3 by 1. Now the frequency of 3 will become 2. So here you can see that this 3 is a leaf node because it does not have any left or right children. So here you can see that in the frequency, we have only one odd number. So we can say that 2, 3, 3 is one possible palindromic sequence. Now from 3, we will return to 3 again. So the frequency of 3 will be reduced from 2 to 1. Now from 3, we will go to the node 1. So the frequency of 1 will be increased by 1. Now 1 is the leaf node. So here we can see that the odd numbers are 3 in the path from 3, 2 and 1, which is this path. So here all of the node 1, 2 and 3 appears 1 times. So the odd number is 3. So this path cannot become a palindrome. Now from 1, we will return to 3. So here we have to decrement the value or the frequency 1. And from 3, we will return to 2. So we have to decrement the frequency of 3 by 1. So let's erase it from the map. And here from 2, we will go to the node 1. So we have to increment the frequency by 1. And from 1, we will go to the node 1. So the frequency of 1 will become 2. Now 1 is a leaf node. So here in the map, the frequency of odd number is 1. So we can say that 211 can another palindrome. So from 1, we will get back to the its parent 1, and from 1, we will get back to its parent 2, and from 2, we will return. So far, we have found 2 of the pseudo-palindromic path from root to leaf. One is this, and another is this. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named pseudo-palindromic path, which has a tree as a parameter. Now we are calling a DFS function into the tree, and inside the DFS function, if root is null, we have to simply return. Otherwise, we have to increment the frequency of root value by 1 into this map. And if current root is leaf node, that means it does not have any of the left or right children. We have to check how many node has the frequency of odd number. And here, if the frequency of odd number is less than is equal to 1, we have to increment the answer. Finally, we have to recursively call the DFS function into the left subtree and into the right subtree. And before returning from the current root, we have to decrement the frequency of root value to the map. Finally, we have to return the answer into the pseudo-palindromic path function. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.